Circuit analysis, analytical circuit analysis, analysis syllabus, 5th unit, wattmeter, power factor, angle calculator. In this video we see Lake and Man Engineering. Welcome you all. A vector diagram of a circuit shown in figure. Since the load is assumed to be balanced, we can take Z1 angle of phi 1 is equal to Z2 angle of phi 2 is equal to Z3 angle of phi 3 is equal to SZ angle of phi for the star connected load. Assuming RYB phase sequence, the three RMS load phase voltages are VR and VYN and VBN, that is load phase voltages. IR, IY and IB are the RMS line currents. These currents will lag behind the respective phase voltages by an angle phi. An inductive load is considered. We cannot strictly define the power factor in the three-phase unbalanced circuits as every phase has a separate power factor. The 2 wattmeter method, when applied to a measured power in a three-phase balanced circuit, provides information to calculate the power factor to the load. Vector diagram explanation continuation. Now consider the readings of the 2 wattmeter in figure WR measures previous class figure shown in. WR measures the product of effective value of the current through its current coil IR, effective value of the voltage across its presence coil VRB, and the cosine of the angle between the phases IR and VRB, the voltage across the pressure coil of WR. We found equations phase difference. VRB is VRN minus VBN. In this way, VOB is VYN minus VBN. WR plus WY is root 3 VLIL cos phi. That is, WR is VLIL cos 30 degree minus phi, higher reading. WY is VLIL cos 30 degree plus phi, lower reading. WR plus WY is root 3 VLIL cos phi. WR minus WY is VLIL sin phi. Solving taking the ratio of the upper two values, we get tan phi and phi values. WR minus WY is tan phi divided by root 3. WR minus WY divided by WR plus WY. Tan phi. Tan phi is obtained root 3 WR minus WY divided by WR plus WY bracket. Phi is tan inverse of root 3 bracket of WR minus WY divided by WR plus WY. Thereafter we can find cos phi. That is power factor we find out for cos angle. We know VBN, V1, VYN and VRN as the phase voltages, IR, IY, IB and line currents. Between IR and between the angle phase voltages phi, and 30 degrees between line current and VOB voltages is 30 degree. Circuit analysis. Power factor by 2 wattmeter method, that is ask in 7 mark questions, and total power asked within 7 mark questions. Tan phi is root 3 bracket of WR minus WY divided by WR plus WY. From this formula we obtain phi value is equal to tan inverse of root 3 WR minus WY divided by WR plus WY. That is possibility related possibility 7 mark questions answer. From phi value we find out cos phi, that is power factor value. That is cos phi is power factor. VRB, VYB, VBY, VYR as phase voltages, and VR and VYN and VBN as is a line voltage. WR plus WY is equal to root 3 VLIL cos phi. We found out from vector diagram. WR minus WY is VLIL sin phi. Take WR minus WY divided by WR plus WY is equal to tan phi divided by root 3. We already known the formula. From this formula we operate that formula. Active power is WR plus WY. Tan phi is root 3 WR minus WY divided by WR plus W phi. That is important formula. Input power to the three-phase load is WR plus WY. That is first was wattmeter reading and WY is second wattmeter reading. Reactive power is root 3 VL IL sin phi. We know WR minus WY is VL IL sin phi. Reactive power is root 3 into WR minus WY in the format of wattmeter reading. WR plus WY is root 3 VLIL cos phi. WR minus WY is VLIL sin phi. Again I show the vector diagram. Angle between the VYN and line current is phi. That is R point to neutral point voltages. Again we say the formula. Input power to the three-phase load WR plus WI. WR plus WY is equal to root 3 VIL cos phi. WR minus WY is equal to VLIL sin phi. Take WR minus WY divided by WR plus WY is equal to tan phi divided by root 3. Phi is tan inverse of root 3 WR minus WY divided by WR plus WY. WI is first wattmeter reading, WY is second wattmeter reading. Phi is phase angle, power factor is cos phi. Reactive power is root 3 VLIL sin phi. We know WR minus WY is equal to VLIL sin. We know WR minus WI is VLIL sin phi. Reactive power is goes to root 3 bracket of WR minus WY. That is important formula. This is power factor and angle phi formula. This is reactive power and WR minus WY reactive power formula. That is input power to the phase load is WR plus WY. Man, answer. Thank you.